Hello students, so carrying on from the previous video where I made a blunder on a basic arithmetic, we are moving on to the chapter 3J, calculating percentage change, which does line up with, as I suspected, it does line up with the second half of the Math Helder's question when she was on shopping. So there are some key ideas, and look, I've just taken this straight from the textbook. Haven't had the luxury of time to throw this beautifully together in notes, so I hope you can just read them off. So we got profit will be how much you sell it for, and remove the cost it was for you yourself to purchase. Like if you're the company, whatever you sell it at, remove the price you had to buy the product in the first place. That will give you your profit. And if we look at your loss, some things just don't go to plan. So, maybe customers aren't willing to buy it for what you had to fork out your money for. A common example of a loss would be things like, I know it's a bit hectic right now, but it used to be the case that if you bought a car brand new, and then you try to sell that car, like maybe 5-10 years later, you will not recuperate the full cost that you initially paid for that car. Nobody wants to pay full price for a really old car. So from that transaction, you make a big loss, traditionally. But I think car prices are a bit crazy right now, so second-hand cars can be quite expensive too. So we've got profit and loss. We've got how to calculate the percentage change or profit or loss. Basically, it's going to involve some sort of fraction form, and you scale it by a percentage. Another one that is particularly special is calculation of percentage error. And I'll come on to this one a bit later in this little video. Coming from a science background, I have a bone to pick with how they presented this in the book. Okay. Look, these are pretty straightforward as well. Ripping these ones from the book. So calculate the percentage change, whether it's a profit or loss, when $25 becomes $32. So I think this has got to be like the first number is usually your initial price, and then the second one you have is your final. The word in between might give you a clue as to if these are back to front. So if maybe they're back to front. It'll depend on the word that's in between the two numbers. But I think when we all read this, I think it's quite clear that 25 was the original cost. Whatever the original cost was, that's going to be on the bottom. So we got $25. That was our initial cost. I'll color it in purple. And what the final cost is right now is $32. So I've just taken that information and I have expressed that into a fraction form. Now it's asking us for a percentage. So whatever this is, it'll give me a decimal answer. To change a decimal into a fraction, to change a decimal into a percent, I need to use this method, which I have always called the Bygraves trick, or the Bygraves step. This one is kind of like what we're seeing over here, but we just don't have that one underneath of it at the moment. So here we go. The first step of the process would usually involve, can I use a calculator? No. Simplifying wherever possible. Now we're back to arithmetic again, which I'm not great at when I'm sick. 32, can I divide that by, well, yes, divisible by 2, divisible by, oh, look, I'll go diagonal, actually. Rather than trying to do a vertical simplification here, this is definitely the way to go. Let's do a diagonal there. I can divide them both with 25. So if I do that, this becomes a 1, that's nice. And then this divided by 25, that's 4 of them, so a 4 now. That's a lot simpler to do. And so I don't screw up again on video, I'm going to do this the long way around. You can yell at me on the screens, I'll hear you from yesterday. Alright, 4 times 2 is 8, 4 times 3 is 12. So we should have 128, not $128. We're actually a percentage now. Sorry. I did a bit of an autopilot just now, and then okay, well, let me just backtrack. I put that there. And when I looked at it, I was like, that's not right. My answer, I don't know if you could follow in that brief microsecond where I just sort of go, oh, what happened there? When I put that down, I remembered, I looked at it as like, that doesn't make sense because look at the size, all the original numbers I'm working from. It can't be $128. It doesn't make sense. And the question's asking for a percentage. So in that microsecond where you just saw me like back, I realized that it's not an answer in dollars, of course. If you're smarter than me, you would realize that this is still around. There it is. So the answer is 128%. Does that make sense? Have we got a final price that's 128% of the original, which is the initial? And I think that's about right. Just, it seems to line up. $32 seems about 128% of $25. That's basically the process. So if I repeat that over here, so $60 becomes, okay, what's my initial? My initial number is here, and that goes on the bottom of my fraction. What's my final number? It'll be that, so this will look like a normal fraction. Look, I think the only thing we can go wrong here is that maybe, one, you should just forget to turn it into a fraction form to begin with. The other thing you might screw up is that you might have these the wrong way around. So just keep in mind, your initial or your reference point should be on the bottom. I don't know, it's just something you'll have to memorize. There's no trick for that. Sorry. So once I've got that, now I need to convert that, because that'll just give, if I just punch that, I will get a fraction, or if I do that on a calculator, I will get a decimal answer, which is not what we're looking for, because they're asking us for percent. So I need to scale this, or turn this into a percentage, so I'm going to use the Bygraves trick. And now I'm just going to use the same process as before. I'm actually going to skip over most of these steps here, because it looks like I'll have to do some more hard work that I can't do in my head. But you basically do the same thing I did over here. You simplify and you multiply. And you should get some number in percentage. I won't force you to watch me struggle with trying to divide 48. Okay, returning to the one I screwed up in the last video, as I suspected. Look, you saw that I suspected that something was wrong. And knowing that I tend to make mistakes like this on exams or under time pressure especially, I always go back and do like a double check. So you could see in that video where I said if I did something wrong, it'd be this step. I knew in my gut that that wasn't, didn't sit happy with me. I thought I did that too quickly, and I would have, at the end of the video, I would have gone back and checked my answer before submitting my exam paper. But you're all smarter than me, so you wouldn't have that issue, of course. But this number here should have been 64, and then that would change my final answer to like 224. 224. But you're all smarter than me, so you wouldn't make that mistake, of course. Returning back to this one here. Oh, let me just... I will need this value here that I didn't finish for the dress, the cost of the dress. So let me just quickly hash this one out. 110, take away 22. Then it'd be like 88. I have to borrow. I've forgotten the method. And you borrow from 11, that makes it 10, and you put another one there. Is that how it works? Yeah, 88. Sorry, it's been a while since I did this by hand. So if the final price there would be, she paid for the dress, so I must put the unit there, otherwise I don't think I've answered the question fully. So we got the price of the dress. Wonderful. Let's return to the other bit that I was referring to, that the purple part of the out of the word-based problem, the purple bit is lining up with this video's content, which is you get some information, we want you to tell me the percent. She paid $85 for some shoes that used to be $150. Now, if you recall from our first step here is what is my initial number and what is my final number? My initial or my reference point should always be in the bottom of my fraction here for this to work. So it says it used to be $150. So that will be in the bottom of my fraction. So $150. The price is now $85. And now that would give me a decimal, or it would give me a fraction as a result. So I'm just going to use this trick here. Actually, maybe I can do a different trick here. If I can divide them with 3. No, if I can divide that by... No, I'll carry on as usual. So divide by 10. And now I look at 85 and 15. Can I divide them both with... Can 15 fit in there? Let me just quickly hash this one out because I don't want to screw up twice in the video. 45, 60, 75. No, okay, so it's not going to work. So let me just divide the answer by 5. So if I divide this with 5, I get 3. If I divide this with 5, that gives me 1 there. 5 goes into 80. Goes into 80, is that 16 times plus the one I saved? 17 times. Let me quickly check that with Siri. What is 17 times 5? Okay, I was correct. Wonderful. That way the video is not compromised by my inability to do arithmetic on the fly. Now we should get an answer of 170 over 3, and that percent sign gets copied down here. Now I'm not quite done. I need to turn this into... When you write a percentage, you're often expected to express as a decimal number. So at this point, I will need to use short division. So let me just quickly do that in short division, which would be how many times does 3 fit into 170? So 3 doesn't go into 1. 3 goes into there. 5 times with 2 remainders. 3 goes into 20. 3 times 6 gives me 18. So it looks like I'll have 6 recurring. So that'll be 56.6%, and that's a recurring number, so I'll put a dot above it. Percentage discount for the shoot. That, look, like I said earlier, where I highlighted because I had a bad feeling that if I did something wrong, it would have been there, which it was. My brain, when I finish doing a solve, I look at my result and I just straight away go, does that make sense? Should my answer be really big or should my answer be really small? So like, how much discount for the shoes? That's a small number, and I think that's about right. This is about 50% off is about half price. Does that match with these two figures here? Is 85 about half of 150? I would think so. So that seems about right. We're in the ballpark, so I'm pretty confident with that. So all I'm doing in this section here is the same process I used here and here. What is the total savings that she got for everything altogether? This is just me trying to be mean with my year 7s in the past, where I was trying to give them some revision sheets to challenge them to be a little bit harder. The total savings. So we got, she saved, I think, my first gut feeling is, can I just add the cost savings that I just calculated for the shoes, and then add that saving cost percentage to the dress, which would be 20%. And is that true? Has she saved like roughly 76.6 recurring percent off of her total sale? Let me just quickly check that. So another way of checking would be to look at the total that she paid versus how much it should have cost in summary. So if I'm not sure, which I presently am not sure right now, so she paid, so my reference point, what did the price initially start off as? We had initial price for the shoes of 150, and the original price of the dress, which was 110. The actual price that she paid for was, we calculated $88 for the dress, so it'll be $88 for the dress, and the cost of her shoes, which we got from the problem here, is $85. And then I would use this method once again as well, just to check to see if that answer and that answer is the same. That's one way I would have done it, just to be sure. Right, I did sort of hint at percentage error, and I had a bit of a bone to pick. And it's because the question in the book makes it sound like people are dumb. Okay, so there's the rule. They've literally told it to you. So if you've forgotten, it's what it should have been versus how far off you were. And then you scale that to turn it into a percentage. So that's briefly what the rule is. But if you read these examples, it sounds like people are dumb. You know, Albert measures the length of a piece of timber at 24 centimeters when actually it's 25 centimeters. So it looks like you're referring to people just screwing up. And that's not really how it works in the real world. People don't actively seek out to screw up, and you're not going to measure that with a percentage. It's just sometimes reality will have other factors at play that will affect your result. Okay, so here's another one. Sally measures a bowl of flour at 150 grams when it's actually 160. So it looks like she's screwing up. Look, I think the scenario is not realistic, so let me just give you a realistic scenario. If you don't care, look, you can just stop watching this video right now and move on with your life. If you're curious, then I'm going to go hardcore into some physics here. And this is some maths that you should be able to cope with to some extent. Look, we got an equation here. Don't worry. I don't want you to try to understand it, okay? That doesn't matter. Just take for a fact that this is a rule, okay? Think of it like a hammer is a hammer. You don't have to understand why it's a hammer, okay? Just agree that it's a hammer and it's used for hammering in nails. This is a hammer that calculates how far something has moved if it is accelerating for some duration of time, and also what speed or velocity it started at. Okay, it's just a hammer. It's used to calculate a certain thing. Don't worry about it. So that's, if you're a nerd, there it is. If you're not a nerd, doesn't matter. You can ignore. You can pretend this doesn't exist. Okay, doesn't just okay. So, what I want to get at is like percentage error. Is that sometimes when you take a measurement, things will impact your measurements. So here you can look that there's a cat trying to drop an anvil from a certain height, and Mathilda is holding a clock. She's trying to time how long it takes for the anvil to hit the ground. If she gets that measurement, she can use this hammer, this rule, to calculate this letter. Sorry. Ugh. I'm sorry, students. Now, things are going to go wrong depending on how you do the measurement. If this cat is actually not that high off the ground, then it's going to be difficult for the turtle here to measure this time difference between the anvil in the air and the ground because it's so short. Her reaction time is going to affect the results. Is it because she's screwing up? Is she just messing up? No, she's trying her best. It's just the design, the approach that these two characters are using is flawed. Sorry, I have to cough again. So if you really wanted to do this more accurately, whoops, that's supposed to be a lasso tool. Oh, goodness me. The cat should actually be much higher and higher. That way, the anvil has much more time to fall. And that's easier to measure with a stopwatch. Anyway, so it's the design of the experiment that will influence your final calculation. So if they're doing this experiment and they pump their results into that equation they scribbled out, let's say that they got an answer of 7.81, whatever the number is. Oh, okay, look, this is just a constant. Okay, so you know that pi is a constant, 3.14, da-da-da-da-da. In physics, this letter G is a constant as well, and it has this number. You can forget about that. You'll get to enjoy it when you get to grade 10. But it has a number, so that lowercase g is that number. That's just the way it is. That's its identity. That's what it always is, nearly all the time. If the turtle did the calculation, she got this number. Has she screwed up? No, because it's going to be dependent on how high we were able to drop the anvil. It'll also be dependent on whether the anvil falls straight or does it fall at an angle. It'll depend on the wind resistance because it'll slow it down slightly. So that will change the result a little bit. So if we were to calculate the percentage error, I think I'd rather just shorten it. So I would say percent error equals, it'll be the difference versus what it should be. So I'll put theoretical. And then we would use this 100% over 1 to convert that to percentage. Okay? So if we were to plug all these values in, what's the difference here? So we got, It should have been 9.81. We remove what the total actually calculated from doing some real experiments, from dropping anvils. What should the number supposed to have been? It should have been 9.81. Now we use this sort of maths, and then you would get some sort of answer. Okay, I just wanted to make you aware that this is not, I don't think this is realistic. Some things in life are just hard to measure with absolute precision. And that's just the way life is. Like, for example, another one is, oh God, draw a beaker. Okay, so here's a beaker, and you would fill it up to a certain volume, and you would do your goddamn hardest to get this accurate, yeah? Look, if you're using a beaker to make accurate measurements of volume, you're wasting your time. It's not the right tool for that job. But if you actually tried your absolute best, you did not screw up, you did it, you got like really, really precise, it took about 3 hours to do it, you're still going to be off. Your actual volume in this space will actually be incorrect by some amount. Why? It's because the manufacturer doesn't necessarily make these markings perfectly precise. You know, when they make a piece of glass, there's going to be a little bit of variety every time they make a new piece of glass. So it might be within a certain tolerance range. So if you wanted to go for something more accurate, you would change what type of device you measure volume in. And if you're in grade 12, you would actually know what this thing is. But until then, don't worry. That's the thing that's used for measuring, really, really precise large volumes of water or something. Look, that's the end of the video. Thanks for indulging my loud coughing, long pauses, and my rant here about percentage error. I wish you all the best.